Algebra 2, partner test, 6.1 to 6.3. Question number 1, you've got, for the first one, you've got an exponent outside here. You've got to raise -4 to the second power, which is -4 times -4 is 16. And then 2 times 2 is 4. 3 times 2 is 6. And anything to the 0 power is 1. So you're going to take that and multiply it by 2x cubed yz. The numbers just get multiplied together, so you get 32. You're going to add the x's, so you get x to the 7th. Add the y exponents, you get y to the 7th, and you have a z to the first power. Number 2, you're going to distribute the -3 exponents. So you have 3 to the -3, x to the -9, y to the -15. You multiply those. Then over 2x to the -3, y squared. Now what I'd like to do is I move every negative exponent to make it positive. So this is going to go down here, and it's going to become 3 to the +3. So 3 to the 3rd power is 9, and 9 times 2, 3 to the 3rd power is 27, and 27 times 2 is 54. So you have 54 in the denominator. Then these x's, this -9 is going to come down here, and this x to the 3rd is going to come up here. So you're going to end up with x to the 6 in the bottom. And then the y's, you're going to bring this down here, and you're going to add them, you get 17. Now in the numerator, you just have a 1. For number 3, what I would first do is I would simplify what's inside the parentheses. So I would bring this down here, so you have x to the 6th power. And the y's, 3 of the y's are going to cancel with 3 on the bottom, you get y squared. Now raising something to a negative exponent means to flip it, and then you would square it. So if you flipped this fraction, the 3 would go in the denominator, and the numerator would be the 2x to the 6 y squared. So this is what you have, but you have to square this. So your answer is going to be 4 x to the 12th, y to the 4th, over 3 squared is 9. 3 squared, everything has to be squared. Next one. The cube root of -125 is -5. The 4th root, when you're taking an even, if this number is an even one, the 4th root of 256 is plus or minus. That's when you use plus or minus when that's even, plus or minus 4. Number 6, you can't take, if the radicand is negative, you can't do it if it's an even root, so this is not possible, or no solution. Number 3, 0.3 times 0.3 times 0.3 is 0.027. Number 8, you're going to simplify. 72 is 2, 2, 2, 3, 3, so you're going to pull out a 2 and a 3, you get 6 with a leftover 2, and you've got 6 sets of x that come out, and 3 sets, you're looking for y, so y to the 4th. 4 sets of y, and with 1 y left over. Number 9, 216 is 2, 2, 2, 3, 3, 3. We're looking for sets of 3. So there's 3 2s and 3 3s, that's 6. Now as far as the m's go, you've got 3 sets, and you've got 1 set of n's. The next one, number 10, you're going to take the 4th root of the numerator, which is 2, and the 4th root of the denominator, which is 5. And don't forget plus or minus, because that's an even index. So it's the 4th root. The next one, you are going to plug for this one it says you're gonna use this expression to approximate the visibility range D in miles, so you're gonna solve for H in this problem. So if D is 84, this is what you have, 84 is equal to 1.2 square root of H. You're gonna get rid of this 1.2 by dividing by 1.2, and you get 70, and then you're gonna square both sides, so you get 4,900, and then label, it's in feet. Number 12, you're looking for 5 of a kind, so you're gonna break up 128. 128 is 1, 2, 3, 4, 5, 6, 7 twos. 2 times 2 is 4, times 2 is 8, times 16, 32, 64, and 128. So we're looking for 5 of a kind, there's 5 twos right there. So the answer is 2, and then we have, how many sets of 5 x's do we have? We have 1 set, but we have 2 left over. And as far as the y's go, we have 3 sets. We're gonna take them all out. Next one, number 13. You're looking for the cube root, and you can take the cube root of a negative number. So your answer is gonna be -1 times something. So 2 times 2 is 4, and 2 times 3 is 18. So we're looking for 3 of a kind. There are 3 2's right there, so 2 times -1 is -2. So 2 times the cube root, we've got 9 left in underneath. Now as far as the m's go, I have 3 m's, so we have an m that comes out, and we have 6 n's, so 2 of the n's come out, and we're done. Next one. 2, we're going to multiply 15 out, well 3 times 5 is 15, and we've got 3 times the 4th root of 3, 3, 3. We're just concentrating on the numbers first. So we're looking for 4 of a kind, and there's 3 3's, and there's the 4th one. So 2 times 3 is 6, but we have 4 3's here, so 6 times 3, we've got a big 18 outside. Now there's going to be left underneath a 5. Because there was nothing to pair this up with. What is, as far as the variables, we have x to the 11th power, but we're looking for sets of 4 of them. So that would be 4, 8, we've got 2 sets, and then we have 3 left over. Next one. You are going to rewrite the 54 here, and that would be 2 times 3 times 3 times 3. So we're taking 2 of these 3's out, you get 15 root 6 plus 4 root 6. And then this 3 root 2 times 2 times 2 times 3. So we take this 2 out and we have 6 root 6. So your answer is going to be 15 plus 4 is 19, and 19 minus 6 is 13. The answer is 13 root 6. You're just adding the coefficients. 15 plus 4 is 19. 19 minus 6 is 13. Number 16, you're going to multiply. 6 times 5 is 30. 6 times 3 root 3. 3 root 3 is 18 root 3. And then minus 10 root 3. And then negative 2 root 3 times 3 root 3. Negative 2 times 3 is negative 6. And negative 6 times 3 is negative 18. Adding like terms, 30 minus 18 is 12. And 18 root 3 minus 10 root 3 is 8 root 3. So these two go together, and these two go together to give you 12. Now these are not like terms, so don't add them together. The next one is the difference of 2 perfect squares. All you have to do is multiply the first 2, you get 49, and then always a minus sign, because it's negative times a positive, and root 6 times root 6 is 6, and then just subtract, you get 43. Number 18, you've got double root 3 plus 7, 2 of them. Root 3 times root 3 is just 3. Root 3 times 7 is 7 root 3 plus another 7 root 3. That gives us 14 root 3. Okay, and then 7 times 7 is 49. 49 and 3 is 52. So the answer is 52 plus 14 root 3. So what I did was I added these two, 49 and 3 is 52, and you have two 7 root 3s, which is 14 root 3. Next one is, this is the same as this problem, number 15, except we're looking for 3 of a kind. So we're going to take 24, and 24 is 8 times 3. So we've got 3 2s and a 3. So it looks like 3 of these 2's come out. You get 4 root 3, 3. 4 times the cube root of 3 plus, now 81 is 4 3's, so this is going to be 3 times the cube root of 3. And then 16, we've got plus 3, the cube root of 16 is 4 2's. So when you do this one, you take 3 of the 2's out, you get plus 6 times the cube root of 2. Now these two are alike, but this one's not. So when you add these up, you can only add these two. You get 7 times the cube root of 3 plus 6 times the cube root of 2. Number 20, when you're dividing and the indexes are the same, think of this as a fraction 4/12, and then x to the 8th over x to the 6th, y to the 5th over y to the 6th. So if you were to just simplify this fraction, what would you get? 4/12 reduces to 1/3. And then you've got 2 x's on top, and you've got 1 y on the bottom. Now you're taking the square root of this, so look for 2 of a kind. There's 2 x's, so you've got x over the cube root of 3y, which we don't want a radical in the denominator, so we have to rationalize. So your answer is x root 3y over, we've got a pair of 3's and we have a pair of y's. Done. 21, same thing, same concept. We have a cube root, so think of this fraction as 20 x cubed y to the 4th over 4x to the 4th y to the 6th. 4 goes into 25 times. And we've got 1x on the bottom and 2 y's on the bottom. So now we're looking for cube root. So for the cube root of these now, you can't have a radical in denominator. So we're lacking 2 x's and 1 y. So we do that to the top. We need 2 x's and 1 y. So on top you have the cube root of 5x squared y over an xy. And the last problem, you're going to want to rationalize the denominator here. I put parentheses around this.